Welcome to Pathfinders, a hiking podcast with Brian. I'm Brian Hudson, and today we're tackling essential outdoor navigation without GPS. Batteries die, screens crack, fog rolls in, skills endure. I'm joined by my friend Ryan. Thanks for being here. We'll unpack how to plan routes, read topography maps, use a baseplate compass, and stay found with pace, time, and terrain. Expect drills you can practice at a local park, safety must-haves, and one actionable tip you can use on your very next hike. Let's start high level. Why does mastering non-GPS navigation matter for both seasoned hikers and folks taking their first steps onto the trail? Right now, especially.
Great setup, Brian. Non-GPS navigation matters because it gives hikers independence, redundancy, and sharper decision-making when conditions change. Batteries drain faster in cold, tree cover blocks satellites, and technical failures happen. If you can read the land in your map, you make safer route choices, pace more efficiently, and conserve energy. It also boosts awareness. Contour lines turn into real ridges and drainages, and you start predicting what's ahead rather than reacting. We see morale rise when people know exactly where they are and how long the next leg will take. That confidence prevents risky shortcuts and helps teams communicate clearly. The best part, these skills are learnable through small reps long before you face your first difficult obstacle.
I love that point about predicting what's ahead. When we run field courses, you can literally watch stress levels drop once folks connect contour shapes to the hills in front of them. It turns the trail into a readable story instead of a mystery. And I've had my own battery nosedive on a cold, miserable day. A paper map and compass saved the outing and our timeline. Let's ground people in map fundamentals next. If someone prints a 124,000 topo for a nearby state park, what should they examine first? I'm thinking scale, contour interval, legend, grid, and that little declination diagram many folks gloss over. Also, how do you orient the map to the terrain so it actually speaks to you?
Start with the map's scale and contour interval. On a 124,000 USGS quad, 1 inch equals 2,000 feet, and 40-foot contours are common. Tighter lines mean steeper slopes. Use the legend to decode symbols and note the grid, UTM or lat long, so you can describe locations precisely. Next, study landforms, ridges, saddles, spurs, and re-entrance. Trace a drainage downhill. Notice how V-shaped contours point upstream. Then check the declination diagram for your area's magnetic offset. Before walking, orient the map. Lay it flat, rotate it until terrain features line up with the real world, and use your compass to align north on the map with magnetic north, accounting for declination. Now, the map mirrors reality, every single step.
That mirror effect is huge. When the map and ground agree, choices feel obvious. Quick add. Drawing a fat pencil line along your intended handrail, say a creek, makes micro decisions easier in thick woods. Let's talk compasses. People see a base plate and a spinning needle and think magic, but there's a workflow. Can you walk through the key parts, base plate, bezel, orienting lines, and arrow, and how to set local magnetic declination? Then the two essential skills, taking a bearing from the map and following it in the field, and the reverse, shooting a bearing to a landmark and transferring it to the map. Also, when and how to use a back bearing to confirm position, especially in feature-poor, confusing terrain and at night.
Let's start with the transparent baseplate. The transparent baseplate shows the map with edge rulers for measuring. The bezel turns and has degree markings. Inside it, orienting lines and the orienting arrow align with the map's north-south grid. The magnetic needle points to magnetic north. Set local declination by adjusting the bezel or the internal screw so the orienting arrow offsets from the needle by your area's value. Now, let's take the map to the field. Place the base plate on start and destination, align the edge, rotate the bezel to match grid north. Then, hold level and turn until the red needle sits in the orienting arrow. Follow the travel arrow. Field to map. Cite a landmark. Read its bearing. Plot that line. Back bearings, verify or relocate.
Clear and actionable. I like that you emphasized aligning with the grid before moving. So many errors start with a sloppy setup. Let's zoom out to route planning, because good plans make the compass work easy. When we prep a day hike for clients, we sketch a route that uses obvious handrails, set checkpoints we can confirm on the move, and pick attack points for precision. We also decide on catching features and bailout options. Can you outline that workflow step by step? And fold-in timing. How do you estimate duration with Naismith's rule and then adjust for elevation gain, heavy packs, or rough surfaces, so pacing and nutrition breaks stay realistic?
Here's the workflow. 1. Identify a start, destination, and big picture handrails, ridges, trails, rivers. 2. Break the route into legs that end at checkpoints you can't miss, a bridge, junction, saddle, or stream bend. 3. For precision, choose an attack point near the target, then navigate a short bearing into it. 4. Draw catching features, roads, major drainages, cliffs, beyond each leg so you don't overshoot. 5. Mark bailout routes to safe, simple terrain. Naismith's rule says 3 miles per hour plus 30 minutes for every 1,000 feet of ascent. Adjust slower for steep descents, heavy load, technical surface, heat, or altitude. Log actual times to refine your pace model and schedule fuel and water breaks accordingly.
Love the checkpoints and catching features. Those are like guardrails for attention. I'll add that writing leg intentions in pencil on the map keeps the brain honest when fatigue creeps in. Let's tie distance into the picture. Knowing how far you've actually traveled is huge for staying found. Walk us through building a personal pace count on different terrain and how to track it without staring at your watch. I'm thinking pace beads, tally marks, or quick notes at checkpoints. Then connect the triad: bearing, distance, and time. How do you blend those inputs so you can say, with confidence, we should hit the re-entrant in 3 minutes or we recheck assumptions? That feedback loop prevents compounding errors beautifully.
Calibrate your pace on known distances. Measure 100 meters, walk it 3 times with your typical pack, and average steps. Repeat on rough ground and steep grades. Log separate counts for flat, uphill, downhill. In the field, use pace beads. Slide 1 small bead every 100 meters. Drop the big bead each kilometer. Tally marks on a notepad work too. Combine bearing, distance, time. Plan a leg at 320 degrees for 600 meters over moderate terrain. Pace, count 6 beads, expect roughly 10 minutes. If you're short on time but have 6 beads, you likely slowed in poor footing. If time matches but beads say 4, you probably drifted or cut a corner. Reassess immediately. Check landmarks and contour handrails.
That diagnostic is gold. Using mismatches to ask the right question beats guessing every time. Let's say someone's on a broad wooded ridge and the trail fades. They're not lost, but they're unsure within a few hundred meters. This is where triangulation and resection shine. Can you break down how to use 2 or 3 visible landmarks to pinpoint position on the map, including what to do if one bearing is ambiguous? And when trees block views, how do you combine a single sightline with contour matching to tighten the estimate? Practical tips on drawing those lines, handling back bearings, and accounting for declination will help people practice without frustration, especially in fog, dusk, or patchy visibility out there.
Let's look at triangulation next. Identify 2 distinct landmarks you can see and find on the map: peaks, towers, lake corners. From your position, cite the first, read the bearing, convert to a back bearing, add or subtract 180, and draw that line on the map through the landmark. Repeat for the second. The intersection is your location. A third line confirms. If one bearing seems off, weight the intersection toward the agreement of the other 2. Resection is similar when you're on a mapped line feature, like a ridge or road. One back bearing to a landmark pinpoints your spot along that line. In limited views, take one solid bearing, then use contour shape, slope aspect, and drainage to tighten the circle.
Great breakdown. I'll add a field note. Draw thin pencil rays for your back bearings, so you can erase later and keep the map readable. Beyond tools, hikers love natural cues. They're not foolproof, but they're excellent sanity checks and backups. Could you run through practical ones people can test today? Sun angles and shadows, using Polaris at night, slope aspect clues, drainage patterns, prevailing winds, and vegetation hints like moss or snow distribution? And just as important, where are the limits and traps with those cues, so listeners know when not to trust them? I want folks using nature as a partner, not as a single point of failure. Layer cues, verify often, and prioritize safety everywhere possible. Use notebooks to track learnings.
Here are some tips when using the sun to help you navigate. Before noon, the sun is generally southeast to south. After noon, it arcs southwest to west. A stick and shadow method, mark the shadow tip, wait a few minutes, mark again, gives an east-west line. At night, Polaris marks north above the Big Dipper's pointer stars. Aspect, south-facing slopes are warmer, drier, with thinner snow. North-facing hold moisture and snowpack. Drainage, small channels feed larger ones, trending downhill toward valleys. Winds, tree flagging and cornices reveal prevailing directions. Vegetation, lichen and moss favor moist sides, but vary regionally. Limits, clouds, canyon walls, and seasonal shifts can mislead. Local wind eddies and human disturbance skew patterns. Treat natural signs as supporting evidence, never sole proof. Cross-check with a map, compass, and contour. Practice under different light conditions.
That's a great sanity checklist. I like using aspect with temperature feel. If my face warms when I traverse, I know I've moved on to a sunnier slope. Now, let's step into the hard stuff. Poor visibility. Fog, dense forest, or night travel can shrink the world to 30 feet. What tactics keep people precise without rushing? I'm thinking short navigation legs, deliberate aiming off to hit a handrail, leapfrogging with a partner, and disciplined dead reckoning with frequent checks. Then error management. When something doesn't line up, how do you apply STOP? Stop, think, observe, plan, correct drift, relocate from your last known point, and decide when to bail or turn around.
In poor visibility, shorten legs to features you can confirm, 50 to 200 meters. Use aiming off. If the stream lies north-south and you're approaching from the west, aim slightly north so you know to turn south upon contact. With a partner, leapfrog. One holds the bearing while the other walks to a visible point. Trade rolls. Dead reckon by bearing, pace, and time, but check often. Errors, STOP, halt movement, breathe and prevent bad momentum. Think about last confirmed features and expected next one. Then observe. Contours, slope aspect, sounds of water, wind direction. Then plan, drift correction, or relocate by returning to your last known point. Turn back when timing, visibility, or energy crosses preset limits.
That preset limits line is vital. Decide them at home, not under stress. What belongs in a minimalist, reliable navigation kit, and what interference should they avoid around the compass? Then connect the training dots. How deliberate navigation can improve pacing, endurance, and mental stamina. I'd love quick park-friendly drills listeners can run this week: the box, triangle, and a contour loop. Also, common mistakes to watch for, so progress doesn't get derailed. Finally, give us one actionable tip for today and a simple weekly practice plan so their very next hike doubles as a navigation workout without feeling like homework. Make it approachable, fun, and immediately rewarding for every level.
Here's what you need in your kit. Quality adjustable declination baseplate compass. Waterproofed 1.24,000 topo in a zip bag. Pencil and small notebook. Whistle, headlamp, emergency layer, analog altimeter or altimeter watch. Keep phones, knives, and magnets away from the compass. They can swing the needle. Fitness tie-in. Nav legs create purposeful intervals. You hike at sustainable effort, recover at checkpoints, and build mental stamina through focused reps. Here are some great drills to help you. Map orientation walk. Four-leg box with equal bearings and distances. Triangle bearings returning to start. Contour interpretation loop. Mistakes. Skipping declination. Holding the compass near electronics. Not orienting the map. Chasing cairns. Checking too infrequently. Here's a great actionable tip for you. Calibrate your pace count and make a 10-bead counter. Then use it on your next hike.
That's a masterclass. Today we covered why non-GPS navigation sharpens safety and awareness, map fundamentals like scale, contours, grids, and declination, compass skills for setting declination, taking and following bearings, and using back bearings, route planning with handrails, checkpoints, attack points, catching features, and bailouts, pace and distance systems, triangulation and resection, natural cues with their limits, tactics for poor visibility, error management with STOP, and a lean navigation kit that avoids interference. Your actionable tip: calibrate your pace count and build that 10-bead counter, then run the weekly 60-minute practice. This is how hikes become smoother, fitter, and more intentional. Thanks for listening to Pathfinders. Hike smart, stay found, and we'll see you on the trail very soon.